Yeah, we are live.
Right. Good evening, everyone. Welcome to day four of MLRW 2023, brought to you by the AI Club of Anti Guwahati. Today, it's my pleasure to welcome our esteemed guest, Mr. Abhishek Santhanam. He's an applied research engineer at LinkedIn, and he works in the content quality fairness team. He has also previously interned at Microsoft and Amazon. As we all know, in this digital age, the spread of misinformation and hate speech on social media has become a significant challenge. So, today, Abhishek sir will be sharing his expertise on the state of the art defenses against misinformation and the importance of fairness and content moderation on social media. So, without further ado, over to you, sir.
Hey Chandrasekhar, thank you for the introduction. And yeah, so I'll be talking about content moderation in social media. So let me just share my screen so that I can pick up my presentation. Cool. Let me know when it's visible.
Yeah, we can see.
Awesome. So yeah, just to give you some context about myself, I started off with my career in ML during my second year, where I interned at a startup, and then I did some basic courses at IITM and got did my interns at Microsoft and Amazon. And after that, I have been working at LinkedIn in the content moderation team. So that is about me. And today I'll mostly be talking about uh, content moderation specific to two broad topics. One is the misinformation side, and the other one is how fairness is measured as well as mitigated in such uh, areas. So there are different types of content being moderated by different platforms. For instance, Twitter has different policies and LinkedIn has different policies. But one common thing that all the platforms aim to do is reduce spammy content to its users. So these are some of the types of content that Twitter moderates. So it could be something which is violent, or something which is spammy, or which is not safe for work, etc. So a lot of there are different types of defenses could that could be used in such settings. So the first defense, which we'll be talking about in detail, are the automated detection systems. So these automated detection systems could be of different types. These could be simple binary classifiers, which classify a particular content as spammy and not spammy. It could be near-dupe systems, which essentially try to capture similar content and use a pre-existing knowledge base or an index which has information about whether the content that is currently under review is spammy or not. So to give you a more better idea on that, it essentially looks at the similarity with pre-existing labeled content and checks if that's spam or not. There are other automated detection systems which we will talk in detail later, but this is the broader overview. The next type of defenses are human moderators. Human moderators view content on a daily basis in almost all social media companies. They are trained on these policies and are the backbone of most of the content moderation systems in two ways. One, they provide the data, the labeled data that is useful for all the automated systems. And they also look at some content for which there are no defenses and which could potentially be spam. So those type of content are purely caught by these human moderators. Human moderators might be both internal and external. How we can use external human moderators are by using member reports. So we almost all social media companies have a prompt or an option to report posts. So this also acts as a very important type of defense in handling spammy content. There is another type of defense which is a combination of these automated defense systems and these human moderators. So sometimes companies build weak defenses, which might not be uh, very accurate, but they sample only a small data which they are confident about and send it to these human reviewers. This ensures that the human reviewer does not have to see all the content on the platform, and hence it saves on a lot of time for the human reviewers as well as cost for the company. Uh, so that is a brief overview of content moderation in social media. So I will take any questions if there are, or we'll continue.
Uh, yeah, for now, I don't think there are any questions.
So let's dig deep into misinformation detection. Uh, so there are different types of content that is seen in in all the social media platforms. So they could be of different modalities. It could be text, it could be images, it could be videos, it could be memes, which are essentially multimodal data, which is a combination of image and text, or it could be a single post, which is a combination of an image and a text, or videos and text. And each of these contents are handled by different defenses. For instance, text, you you all might have known the evolution of text-based large language models, which have been the backbone of such defenses currently. Uh, they have it's mostly em- embedding the text and building classifiers to predict whether it's spammy or not spammy. And there are image-based models like EfficientNet, which provide an embedding for the images, which can again be used with neural networks to build classifiers. And these embeddings can also be used to build near-dupe systems, as I mentioned. So we first label the content as spammy and not spammy, generate their embeddings, and store their embeddings along with the information as to whether they're spammy or not spammy. And when a new content arrives, we compare the embeddings of that content to the existing embeddings and have a threshold for the similarity metric. We can use different kinds of similarity like sign similarity or the Euclidean distance. So we use some kind of similarity metric over there, and we check if the content that is presented to the defense system is similar to any of the content that is present, and label the presented content as spam or not spam using that. So for videos, it is mostly handled as frames of images, and we use different neural networks to handle it. So as I had mentioned, there are different content-based approaches, which could be deep neural network based, or they could also be Neodyp based. So Neodyp systems have different types. It could be syntactic similarity, semantic similarity, or sometimes even URL based. For instance, most of the text content that comes up has a small amount of text and the URL followed by it. So there are two approaches in handling URLs. One is you handle the URL as is, or you try to extract the content inside the links and use similarity metrics on those content. For syntactic similarity, it's mostly sentence wise and other embedding based metrics. And for semantic similarity, you have graph based approaches like semantic graphs or fuzziness based approaches. So the next part is about of defenses is about knowledge based methods. Knowledge based creation is a very important step which essentially involves claim extraction and claim detection. We take a particular post and extract the claims. So why are we looking at claims over here? Misinformation is mostly driven by claims. A particular piece of information is either true or false, and that piece of information is the claim in the article. So instead of examining the entire article, we look to extract only the claims in the article and we analyze those claims. To create a knowledge base with only these claims, we first build a claim extraction model. This can be done by the various summarization models that exist, like GPT. And there are two types of summarizations that can be done for claim detection. One is the abstractive summarization, and the other is extractive summarization. So, extractive summarization means you extract sentences from the article. It is not a generative model, but it is more of a extractive model. Essentially, it extracts the sentences. And abstractive summarization tries to generate a summary from the given article. It need not contain words or sentences only from the input article. It makes more sense to use an extractive summarization in this case, as we would like to have sentences from the article to compare. And once we do extractive summarization, we store each of those texts in a knowledge base with the information as to whether it is true or false. And this would help answering the question as to whether a new claim is true or false. So when there is a new claim, we do some kind of semantic or syntactic similarity with the existing knowledge base and see if the similar content are marked as spam or not spam, as in misinfo or not misinfo. So this again talks about how the knowledge base is used with Neodyp techniques and how we can use it to predict how a new claim is misinfo or not. The next and the most evolving approach is the graph-based approaches. So, firstly, let's talk about the different types of graphs that are present in social media. There are activity-based graphs, which could be any activity, like you can perform, you can this essentially stores all the activity that is performed by a user on a content. So activity like liking a post, commenting on a post, sharing a post, or even like the time for the time of viewing a particular post could also be used in the activity based graphs. And content similarity graphs are essentially graphs which map similar content with each other. And here, the edges could be weighted in the sense that they could have a weight which is proportional to the similarity metric that is being used to define the contents similarity. For instance, if you're using cosine similarity, you can take two images, take out their embeddings from any standard CNN, and see how the cosine similarity values are. You generally have a threshold or to see if it is actually similar or not. But in this case, when you use it as a weight of a graph, you can directly use the value as the weight. And the third type of graphs that are present are member graphs. So member graphs could be graphs between people, essentially uh, showing relationships like first connection, second connection, third connection, and also showing relationships like following or blocked or so these kind of connections form the member graph. Looking at graph-based approaches, so there are different types of graph-based approaches. The first is where you engineer the graph features. Essentially, you have a deep neural network to which you provide a set of features. These features are engineered here in the sense that you can take different properties of a particular graph and model the points. So you can take model the vertices. So you can take features like node degree, which is essentially the number of neighbors a particular node has, and you can take the clustering coefficient. You can take the distance between the nodes. So this can be represented as a matrix as shown here. And you could also take the adjacency matrix in different forms. Like the adjacency matrix could just store the distance between the nodes, or it could just store if there are connections between nodes. Or sometimes you might also want to see a power of an adjacency matrix. So from graph theory, you might have studied that a square would, if A is the adjacency matrix, a square would provide you with information as to how many nodes or uh, whether two nodes are connected by second by edges of distance 2, and a cube would be providing information as to whether two nodes are connected with edges of distance 3. So these kinds of mo- modifications to adjacency matrix can also be used in these engineered features. And at times, instead of using the entire adjacency matrix, you can also use features of the adjacency matrix, like you use the trace of the adjacency matrix or the rank of the adjacency matrix, and so on. So graph-based approach, the second type of graph-based approach is a graph neural network, where we provide as input the graph, and in each hidden layer, you have different forms of the graph, and as output, you have the graph again with information as to whether a particular content is spammy or not spammy. I will not be going in detail about graph-based approaches because that is a complete topic by itself. So I will keep it short over here. And the other type of approaches are hybrid approaches, which are ensembles of the methods that were discussed previously. uh, Essentially you could have multiple graph neural networks running in parallel. You could have another model which is using those engineered features which is running in parallel. You get all the outputs and you then further take the outputs as an input to another neural network and provide an ensemble output. So this is about misinformation in social media. If there are any questions, we can have a brief stop here.
Yeah, there's one question. Are the embedding models mentioned before trained for the downstream spam detection task or retain models work?
That's a really good question. So when we take up a particular problem, we try different approaches. So in some cases, for instance, these large language models in texts, they perform really well. They have good zero shot capabilities in some tasks, like some tasks which are uh, in which it's good at is probably detecting hate speech. But the issue there is each company has its own policy defined. And with a specific policy defined for each company, it gets difficult for these large language models to perform well on the downstream task directly. Hence, we do fine tune these models so we don't train it completely. So the fine tuning is done in the sense that we unfreeze the last few layers of the large language model. And if we want to add some additional features to it, we add it, add a couple of additional layers and train the network for a smaller number of epochs. Because if I have to train the entire large language model on the entire data set, it would be quite difficult because the amount of data set that we have is also quite less for training a large language model, and the amount of time it would take to train a large number of epochs is also less. Is also a lot. So that's why we fine tune these models in this way. Any other questions?
Yeah, there are no other questions.
So let's get into fairness in the content quality space. So before I discuss about the types of fairness, let's talk about why fairness. So there have been multiple events in the past where social media companies have been biased towards a particular group. So with respect to content moderation, for instance, some there have been reports that some companies have taken down posts which supported Black Lives Matter or which supported a particular movement which is not hurtful and which is not causing issues, but it it is purely because of the bias in the data that the models were trained on. So how can we make these models better, or how can we make sure that these do not happen in the future? So to answer that question is where such fairness teams come in. They ensure that the models are both fairness compliant with respect to measurement, and they also try to mitigate these models by adding additional components to it. So let's get into it. So we'll be talking about fairness measurement firstly. Uh, the There are different types of fairness measurement as well. So we will talk about group fairness first. Group fairness essentially is defined as how the model performance should not vary from each group as an entire entity. So here, when we look at groups, let's take the example of gender, for instance, and say we are analyzing the difference in model performances with respect to the male and the female gender. Uh, what they do is they calculate different parameters like precision, recall, false positive rate, false negative rate for these different groups and see how different they are. So if there is a precision of zero point 0.7 for male content, so how, how do you classify content here? How do you classify fairness here? So fairness again can be of different types. Fairness can be based on the content. Fairness can be with respect to the creator of the content, and fairness can be with respect to the viewer of the content. Uh, so we will discuss all of these in detail in the further slides. But I hope you got a good idea about what true fairness means. It essentially sees uh, how the model performance is on different groups and sees how different it is. The second type of fairness is individual fairness. Here, we are not concerned about groups, but we are more concerned about individual data points. So by data points, I mean any kind of content that is being posted. So if, for instance, if there is something that talks about a man and say there is a content which is like he is smart and the misinfo classifier provides a score of 1 to it. But when the he is changed to a she for a text like she is smart, the misinfo classifier gives only a score of zero point 0.8. That is a sign of concern with respect to individual fairness. Where when we change a single entity, the performance of the model varies. So this is what we look to address in individual fairness. So again, fairness can be is very specific to different types of models. There could be fair large language models where we ensure that the embedding representation by itself is fair. And there are fairness for recommendation models where we ensure that the content that is recommended as well as to whom it is recommended is done in a fair manner or in an unbiased manner. And thirdly, the classifiers or the spam classifiers, which is of utmost interest in the content quality team. So how a classifier scores or how a classifier classifies different data points belonging to different groups or individual groups. As I mentioned, there are two sides to fairness. Firstly, there's bias measurement, which is essentially a quantitative measure to understand if a model has any intrinsic bias or this why we mention intrinsic bias here is because these are not intended biases. These are not heuristic models which say that if there is a man in your text, you label it as spam, or if it says if there is a woman in your text, you label it as spam. It's intrinsic from the text it has been trained on. And there are bias mitigation techniques. Essentially, there are modifications to the algorithm, to the machine learning algorithm to ensure that this intrinsic bias is reduced. It is difficult to completely remove the intrinsic bias, so they try to reduce the bias. And this could be as simple as retraining the ML model with an unbiased dataset. For instance, you have a dataset which has 40% representation of males and 60% representation of females. You undersample the female dataset and get a 50-50 sample, which can be used to train, or you use some kind of generative AI to generate examples for the oversampled dataset, which was male in this case. So essentially, you make both 50% and you retrain the ML. Yes. So fairness in the content moderation space. can be of different types. It can be from the perspective of the content creator, as in if the content created by a male is being taken down more than the content being created by a female, then that is a problem. And it could be from the perspective of the content viewer. So the perspective of the content viewer doesn't make much sense over here because everyone sees all the content, at least from the classifier's perspective. It could be a problem when you talk about recommendation systems, but from the classifier's perspective, there is no difference here. So we do not look into the viewer side fairness. The third is the content subject perspective, where we look at the content, the details of the content, essentially whether an image contains a person of color or a Asian person or a person of different nationality, or if a text contains different genders or different races or religion. So that is about the sub content subject, and we look at how our ML models are fair towards the content. And finally, it is about fairness with respect to the content moderators. Uh, Here, this is a very specific uh, thing which is not about the models, but more about the human moderators that are being used here, because they are the source of labeled data for our models. And if the human moderators are biased, then we would be getting biased datasets for training. Hence, we have to ensure that our human moderators have to be unbiased. For this, we look at how different, so we look at how content from different people or content with different content is labeled by the same reviewer and see if there is a discrepancy there. So let's look at bias measurement from a content creator perspective. So in the group fairness measurements, here content moderation metrics like classifier metrics like true positive rate, false positive rate, true negative rate, and false negative rate are the most used metrics in the field of fairness. And when they vary among the different protected attributes. So by protected attributes here, I mean gender, race, religion, etc. So group fairness metrics measures look at how these metrics vary among different protected attributes of the content creators. Individual fairness in the context of content creators doesn't make much sense because it is difficult to change a single attribute for a content creator. For instance, you cannot just change a male and get an exactly equivalent female for them creating content. So that is difficult or near impossible. And hence, we do not look at content moderation using individual fairness when we look at it from a content creator perspective. Uh, as I mentioned, content viewer perspective, it doesn't make sense in the content moderation domain, both from the content, both from the group fairness side as well as the individual fairness side, because the viewers see the same content with respect to this classifier. The only difference that the only model that is causing the difference in viewership is the recommendation system, and hence it doesn't make sense for content moderation classifiers to be measured on the basis of this. Third, fairness with respect to content subject. Here, group fairness measures do not make much sense because there are there may be multiple subjects from different protected attributes in a single content. For instance, if you take an image, you generally don't have just a single person of a single gender. It would have multiple people. It would have females, it could have males, it could have females from different religions or place. So what happens in those cases is that it gets difficult to classify a particular content into a particular group. And because of that, we refrain from using group fairness measurements for uh, content subject fairness. But here, individual fairness is used a lot. As I mentioned before, a sentence like he is very good and a sentence like she is very good shouldn't ideally be getting different scores from a classifier. And this is what we measure using individual fairness measures. Similarly, when there is an image of four female uh, workers versus an image of four male workers or four three male workers and a female worker, the image classifier should not be giving different scores for these two images. And it is easy to generate these images or generate such images than group them into different groups because a single image, as I mentioned, a single image can contain multiple content subjects. With respect to individual fairness measures, we'll be going into more detail here. So there are different methods used for different modalities in individual fairness measurement because the same kind of uh, counterfactual generation. By counterfactuals, here I mean uh, the content, the modified content from a given content for the different values of a protected attribute. This could have been a bit confusing. So let me give you an example. So say the different genders are male, female, and non-binary. Uh, so when you have a sentence which talks about just the male counterpart, you modify the sentence or the words in the sentence which correspond to the male counterpart to its female counterpart and non-binary counterpart and check if the classifier scores differ. So these different sentences that were generated from the source sentence are called counterfactuals. So here, the generation of counterfactuals and the type of measurements used for counterfactuals is very different for different modalities. So as we were talking about counterfactuals, let's dig deep into counterfactual generation for text. One of the naive approaches of counterfactual generation for text is replacing keywords with a predefined set of words. For instance, you have keywords he, him, etc., which correspond to the male gender, and you have a corresponding mapping of these words to the female counterpart. But this is not a very foolproof method because there could be different usage of words for different genders, and hence the more foolproof method would be text translation models or text generator models. Text translation models come somewhere between the naive approach and the generative models because generative models are becoming much more powerful now. But at the start, it was mostly translation models which you could build uh, from which were initially used for language conversion, where you could convert text belonging to a particular language to another language. But from its core modeling perspective, you could essentially translate any text to another text. It purely depends on the data set it is trained on. So if you can train a translation model to generate counterfactuals, that could be a great uh, counterfactual generating approach for text. And finally, with the advent of generative AI and generative text models like ChatGPT and other, GPT-4, you can use these generative models to generate counterfactuals. But again, here, the generative models would not be able to perform well with just the counterfactuals. Like if you ask ChatGPT to generate counterfactuals for a given sentence, it might be able to create some kind of counterfactuals, but it might not be relevant to your policy or relevant to the protected attribute you're dealing with. So it is better to train your own generative model in such cases. And the next uh, type of modality is images. This also applies for videos because videos are essentially frames of images. Uh, Again, the naive approach is replacing parts of the image with a predefined set of image. For instance, how you could do this is if you have images with male with different people, you create object detection model, like say YOLO, which detects the person, and then you classify the person into their respective gender, say male or female. And upon doing that, you replace the face with the uh, opposite face or with a face corresponding to another gender. This is definitely not foolproof, and uh, this is not the recommended method at all. But this is the naive approach that was taken many years back. So currently, most of them use conditional GANs. GANs are essentially generative models and conditional diffusion models. GANs were the talk of the town for the past 3 or 4 years prior to the release of DALI. DALI was an image generative model which used diffusion models, which essentially was able to generate images from noise. So using such diffusion models, the and applying a condition to it, the condition in the sense that you could uh, diffuse a given image of a male to a image of a female, you could generate different counterfactuals for images. So that is how we generate counterfactuals for images. I think I've been talking for quite some time. If there are any questions,
Yeah. Are training data for bias classification auto-generated, like replacing man with human?
training data for bias classification auto-generated. So I don't think so. I got the question here because bias classification is not something that I spoke about. But I think the past two slides that where I spoke about counterfactual generation for texts and for images should have answered this question because it talks about both automated data generation for FAR classifiers as well as naive approaches, which are again automated but are not generative in nature. So let's talk about the different metrics that can be used. I don't think so. I'll be talking about any other metric. Yeah, I'll be talking only about the counterfactual token fairness, which is which is used fairly commonly in almost all fairness measurement metrics. So it sees the scores, which is essentially f of x, and sees how what is the absolute difference in the scores between the counterfactuals. So essentially, if there is a sentence where going back to my going back to the same sentence of he is smart and she is smart, if the classifier gives a score of A for he is smart and a score of B for she is smart and a score of C for they is smart. So again, here if you use the naive approach of replacing the keywords, it would be they is smart, which is not. syntactically correct, but if we use some kind of generative text model, which is generating the text afresh, that would change it automatically to they are smart. So that is another useful use case of generative modeling. And coming back to CTF, if the three scores are A, B, and C, we can see that A should be equal to B and should be equal to C. So for in the ideal scenario. So to understand how it is not, we look at the absolute difference between AB, BC, C, and C and A, and it is unioned. So if we also define epsilon, which is the a particular threshold for these counterfactuals, and if we see that the value of the differences is less than epsilon, then the model is fair. If not, we treat the model as unfair and look for bias mitigation techniques. So epsilon can be defined based on policy or based on how stringent you want to be on making your model fair. So there are different approaches to mitigation. Uh, the first approach being another very naive approach, which is called blindness. So blindness, as it suggests, blinds the uh, details in the content that provide information about such protected attributes. For instance, in texts, it replaces the tokens or words that correspond to a protected attribute, again coming to he or she, with an unknown token. So this would definitely alter the meaning of the text, but doesn't alter the embeddings much. And hence, this was the naive approach that was used previously to see, to make sure that models are fair. But as as time went by, they saw that blindness-based approaches weren't working all that good, and they switched to other approaches where they augmented data to include the counterfactuals that were generated and retrained the entire classifier. So this ensured that we had an unbiased data sample for the training process, and hence that provided us with fair models. The final one, which is one of the more complex approaches and one in which a lot of research papers have come about, is including the fairness metric to the loss function of the classifiers, and how the backprop algorithm or the optimization algorithm can be optimized for this loss instead of the standard losses like cross entropy that are used. So that brings me to the end of my presentation. If there are any questions, I can take them.
Just a minute. I think yeah. Are there methods for bias mitigation without retraining a biased model completely?
So fine tuning of existing large language models have proven to be useful in mitigating bias. So again, if you do not have resources to train an entire model from scratch, fine tuning is a good approach. Also using techniques like distillation models, which are essentially reducing the compute required for large language models. So distillation methods are helpful in retraining the model completely instead of if you want to retrain the model completely using this data instead of fine tuning, you can use some kind of distillation. I hope that answered the question.
Yeah, I think that's all the questions we have.
That's awesome. Yeah, thank you guys for
Yeah.
providing me the opportunity to present.
Yeah,
Feel
thank you,
free to,
sir, for this
yeah, and feel free to
very insightful talk.
ping me any other questions you have on the presentation on any of the social media platforms you find me on, preferably LinkedIn. So, yeah, thank you.
Thank you.